So my talk's on forming clouds with Terraform. Has anybody used Terraform before? Just put your hands up. A couple people. Cool. So to start off, we'll talk about the kind of traditional style to actually building kind of a bunch of resources out in kind of like a data center, and then obviously the cloud eventually. So we started off with like back when I was at university, I actually kind of managed some physical servers as well. I mean, used to take a lot of time to kind of like set them up, plug everything together and everything else, and it was quite a lot of hard work to get another physical server provisioned. And then we went up to VMs, and this is where we created like a physical, we were just hosting more virtual machines on the one physical VM, which could be span across multiple hosts. And that kept being quite tedious as well, because when we were trying to do like one service per VM to keep things quite isolated, we'd have to create a lot of scripts underneath the hood to kind of like provision these VMs every single time we want to kind of move between like development, test, and then live. So this is when we created lots of ad hoc scripts to kind of provision all these VMs. So we use things like lots of package managers and like Chocolatey these days to kind of provision the VMs to the initial state. And then now we've moved on to more cloud infrastructure and offerings. We want to kind of provision these really fast, and then also we want to sometimes destroy them straight away afterwards within like an hour or less. And we can't be having like handcrafted scripts and people kind of plugging in cables, because it's going to kind of take far too long. And with all the DevOps movement as well, developers are encouraged to kind of own the ownership of the delivery process to the end, where kind of the end is kind of an infinite process, so we're always monitoring and making sure things are up. So this kind of feeds back into that process as well, where we take ownership as developers to kind of maintain all our kind of resources as well. So this is kind of where infrastructure as code comes into play, and Terraform is one of these tools. And the idea is it creates a lot of like kind of simplicity behind the hood of kind of just declaratively specifying what resources you need to kind of provision. And this also enables a lot of speed, so you can just say provision all these resources on dev, and then go do them for live, and then test, live and test the way around, sorry. And then also there's a lot of configuration consistency, so creating a lot of ad hoc scripts. There's a lot of different conditions inside them, saying if it's test, then do this other scenario. If it's production, do this other scenario. If you've just got like a baseline load of scripts, what say this is how our state on our resources should look, we can just apply that across all environments, and they all act and work exactly the same. It also minimizes the risk as well. So if something goes wrong with any of our resources, we can just redeploy them, take out like a resource, and just kind of initialize another resource. So that makes it kind of very effective. Increases the efficiency, because we can just kind of plug and play a lot of things under the hood. And one great thing about this, we don't have to have reams and reams of documentation in PDFs. What tells us how to set up these servers, we can just say, here's the code, what like kind of runs, and it shows you in the code kind of what it is. And it also is a massive cost saving as well. So this means you can tear down your test infrastructure at night, and then just provision it all in the morning for the next day. So you don't have to pay for overnight what you're using, not using it. As previously, if you were running it on VMs and everything else, you probably keep them stateful. So yeah, there's a massive cost saving. And one big thing what people go for is it's very auditable as well. So because it's infrastructure as code, it's just like your code. So you can tag the code commits inside Git. So you can store this all in Git and track them on like Jira or any other kind of backlog like tool for your stories. So then you've got a full audit trail of what happened to your system over time. And the great thing is, it's all code, and because we're developers, we love code. So we get source control, obviously. We can review everything using pull requests. We can plug this into our CI/CD pipeline, so every time we do a commit on it, we can just roll out the changes and see how they work. And then we can also apply all the normal software engineering principles. So things like dry, we can start modularizing these kind of scripts. So if we need to provision like a Azure website, we can just use the same template over and over again across all our kind of services. So Terraform is one of these players, like I said. So I'll go into kind of how Terraform works, but there's lots of other different like tools underneath the hood that can do the same similar things. So one of these is ARM templates in Azure, and they're kind of a bit like hard to get going. I find ARM templates, and there's not much tooling around them. And then there's also CloudFormation inside AWS, which is a lot more like Terraform and has a lot more kind of tooling around it to make it a lot easier to use. So Terraform is vendor agnostic. It's one of the benefits compared to using ARM templates or CloudFormation. So they have a load of range of providers from AWS, Azure, Cloudflare, GitHub, MongoDB. They also have a lot of providers which are from the open source community as well. So you can actually write a Terraform provider to go order you pizzas. There's actually one on the community repository. So if you deploy, you can say, go order me a pizza, and I'll go order you one every time you deploy your services. And they act as like a blueprint of your data center. So you're not kind of writing scripts to incremental changes on, say, your database schema. They're your end state. So you're saying you want a Azure website with a network behind it, which is then connected to a database. And that's your end state scenario. And what Terraform will do is build you a change set of what it's going to change on that environment, and then apply them changes incrementally over time. So they don't try to bin everything all at once, bin everything and then recreate it. It'll create you lots of change sets. It's all kind of written in this thing called HashiCorp configuration language, and we'll go into that a bit more later on, but it's more of a YAML JSON kind of language than anything else. But I find it's quite nice to read, to be fair, compared to reading reams and reams of JSON. So as I said, they do incremental execution plans, so this is where it does the change sets. And it also creates you a dependency graph. So say your Azure website relies on the network, it'll go create the network first before creating the Azure website. And the same thing if the Azure website relies on the database, it'll automatically create the database and network first before creating the website. So it can work out all the dependencies, what it has to create on the resources to build first. So you don't have to explicitly say what needs to be, which order things need to be created. So this is what the kind of configuration language looks like. So to start off with this, we have this resource property. And this is like a component, and there's lots of different components. One of them is a resource, and this just tells us we want to create a resource. There's also provider, so if you want to kind of include providers into your scripts, you can do provider and then something else. But this says, I want to create a resource. The second property is what you want to create. So I'm saying I want to create a GitHub repository. And the third one is the name what I want to give it. So if I reference this resource in the script somewhere else, this is the name what I reference it by. And then the rest of the properties in the middle of the body are just all the kind of properties which this kind of resource provider gives us. So for this example, we can give a name description and if the repo is private or not. So the development workflow for how you kind of run Terraform scripts, you start off writing your code like normal. You then call init on it, which kind of creates, initializes your kind of working space. So if you use it like the GitHub provider or the Azure provider, it'll go download all the components what it needs to run. Then you can run a plan, and this will work out from the environment what you're deploying to the change set of what your end state should look like. The changes what are in there for the end state. And after that, you can run an apply, and this will go change all the environment to look like your blueprint. And then afterwards, you can optionally destroy everything as well. So this might not be very useful in production because you probably won't want to destroy your environment every single time you kind of deploy. But if you're creating your environment every time you create a pull request, for example, so say you open a pull request to another team member, it creates all this infrastructure and all the site all ready and working, then your testers can go in, play around with it, and then as soon as you accept the pull request, it can go destroy all the actual resources what it's created. There's a lot of people actually using it in this way, and the company what I'm working for, we're trying to get into this scenario where we kind of destroy things after we've created things, so we can prove that things work, destroy it, and then we can then push it out. So I'm just going to go into a little demo of this. Sure. So this is an example of the scripts. So this is exactly the same what I had on the board. So this says I'm going to include a GitHub provider, and here's my tokens, what I'm going to pass in as parameters. And I'm going to create a repository which is called Terraform Light and Talk Demo. And it's got, this is the description. So if we go to the command line, so all Terraform is written in Go, so you don't need any other kind of things written around it. And it's just like a command line tool. So if you run Terraform, it gives you some options. So I can do the Terraform init. Can everybody see that? Shall I just zoom in? So this has gone off and initialized the project for me. So it's gone off and downloaded the GitHub provider, which is 2.1, and now it says everything's successful and it's ready to roll. So I can do Terraform plan. And what this has done is created me a plan. So it says it's going to create me a GitHub repository. It's going to compute an ID for it, so what it's going to use. It's going to set all these values here. It's also going to set the description, what I've told it to set, which is this is a description. It's going to set the repo name to Terraform Light and Talk Demo. And that's it. That's what it's going to tell it's going to do. So then I can run my Terraform apply. And this will just go look at the plan and say, this is the stuff what's going to change. Do you want to accept this? And you click yes, type in yes. And now it's just going off and creating it for me. So this is going up to GitHub, creating this resource for me, and then calling me back when it's done. So if I go over to so I created in the dotnetsheff account. So here we've got our Terraform Light and Talk Demo repository. It's just created for us. And it's just empty because I've not put anything in it. So what we can do is just incrementally change this. So imagine it's like you're building your infrastructure out slowly and you're changing bits and bobs about it, or incrementing, like we use it for updating our Docker container images. We can go change this description to this hello.netsheff, save that, and then go back to our command line. We can do a Terraform plan again. And this is going to say we're going to change this property on the GitHub repository called myrepo, and we're going to change it from this is a description to hello.netsheff. Pretty simple. So if you just apply that, don't want to do that. So if you do Terraform apply, it'll do exactly the same as before. So it'll say, like, I'm going to change this. We acknowledge that, and it goes away and modifies it for us. So then if we go back to this, to GitHub, and refresh the page, you'll see that it's changed the description for us. So it's not actually destroyed it and recreated it, it's just gone modified it like incrementally. I was going to show a demo of creating an Azure website, but it took between about 1 minute and 10 minutes, depending on how it felt to create it. So that's why I chose GitHub. But you can swap the providers out and it works exactly the same for any of the providers. So you can create like a Mongo database, create anything in AWS or Azure. So one of the things is we can destroy all this stuff because we might want to, we've used it, we want to get rid of it. So you can just do a Terraform destroy. And what this does is look at what is created, and then it goes and works out what it needs to destroy from it. And this is just saying it's going to destroy this repo. Am I okay with this? So say, yeah, I'm totally fine with it. And it's gone and destroyed it. So if you go back to GitHub, refresh the page, and then that's gone because it cleaned itself up. So that's great for scenarios where you want to kind of provision a load of stuff, or maybe you're testing something, and then you just want to bin all the resources to kind of make so it doesn't cost you. So if you're using cloud resources, you might want to destroy them when you're not using them and then recreate them when you want to start using them again. So that's kind of a simple demo as I've shown. But there's some other useful commands. There's Terraform FMT, which formats all the files. So there's no arguing between all your team members. You just run Terraform FMT and everybody has the same coding styles. and there's no arguments, which is quite fun. There's also Terraform validate, which just validates your template actually valid for actual execution. And there's also Terraform console as well. So there's a lot of things where you want to get properties or variables into your scripts, and you want to modify them in a way. So for example, if you're trying to work out some side addresses, or if you're inputting a list into your scripts and you want to kind of create a load of resources based on that list, you can play around in the console just to get the syntax right, which is quite cool. But that's everything for my talk. But thanks for listening.